Okay, so on this lesson, we're going to be going over inverse relations, but before we start that, we're going to have to look at what a function is. So determine if a graph represents a function or not. So it says a relation is a blank if each x value is associated with only one y value. So that is called a function. So the blank indicates whether or not the graph of a relation is a blank. So the vertical line test, or pencil test, if you've heard it that way, indicates whether or not the graph of a relation is a function. So the next part, if an imagined vertical line passes through at most one point, so it can only pass through one point if it passes through a point of a relation at any location. If it does, then that is considered a function. So what we're going to do on this first example is determine if the relations graph below are functions. We're going to justify our answer. So since you can't visually see it, I'm going to just draw vertical lines through this graph on part A and determine if it passes the vertical line test. So if I were to draw vertical lines throughout it, notice it's only intersecting the graph at one point every time I draw a vertical line. So this would be a function, and I'm just going to put it passes the vertical line test. I'll abbreviate. Okay, so part B, we're determining if it's a function. So when I draw these vertical lines, notice it is intersecting at two different places on one vertical line. That means the x values repeat, which means it is not a function. So I'm going to put no, and I'm going to put it fails the vertical line test. So there's repeating x values. Functions do not have any x values that repeat. Part C, same thing. I'm just visually going to draw these vertical lines. Notice it's only intersecting at one place on our graph here, so this would be a function, and it passes the vertical line test. Okay, so that's how we determine if a graph is a function or not. We use the vertical line test. If it only intersects at one place every time we draw the vertical line or look at the vertical line, then that is a function. If it intersects at more than one point, then it is not a function. Okay? So the next part, it says determine if points represent a function. So this time we're not looking at a graph, we're going to be looking at tables, mapping, and then just a list of ordered pairs. So it says check for repeating x values when trying to determine if a table, mapping diagram, or a set of ordered pairs represents a function. Remember, you're checking to see if any of the x values repeat. If they do, that is not a function. All of the x's have to be different. So looking at part A, this is a table. We only care about the x values when we're determining if it's a function. So looking at all of the x values, none of them repeat, so this would be a function. And I'm going to put no repeating x values. Part B, this is a mapping diagram. So if you don't know what a mapping diagram is, these represent all of your x's, these numbers represent your y's. So we're drawing an arrow to the corresponding y value. So this means this here is an ordered pair of -1, 2, and then 0, 1, 0, 3. So hopefully that makes sense. So notice right here, there's two arrows drawn off of this 0, which means that would be a repeating x value. So this is not a function. So x equals 0 repeats. So that is not a function. Now part C, we have ordered pairs. Remember, on an ordered pair, x comes first, then y, so we only care about looking at our x values to determine if it's a function. Notice that those x's are the same, so this is not a function. No, x equals 2 repeats. Okay, so graphically, use the vertical line test to determine if they're repeating x values. If you have a table, order pairs, mapping, you're just checking those x values to see if they repeat. Let's flip on over. Okay, so the next part, what's an inverse? So this key concept here, we will continue to add to our understanding of inverses throughout the year, but we're going to start out with just the basics of it. Let's start with something familiar. So inverse operations blank each other. So inverse operations undo each other. That's an N. The inverse operation of addition, so the opposite of adding, is subtracting, so subtraction. The inverse operation of division would be multiplication, so you're doing the opposite. So example 3, determine the inverse operation of each statement. If we're subtracting 10 from a quantity, the inverse of that would be adding 10. Part B, taking the square root of a quantity. We actually talked about this the other day when we were looking at the parent functions. So square root, the opposite of square rooting something is squaring. Part C, multiplying a quantity by 4. If we're multiplying by 4, the opposite would be to divide by 4. Same thing as that is also multiplying, or the inverse is multiplying by 1/4. That's the same thing as dividing by 4. Okay, so looking at the next part, find the inverse of a relation from graphs and tables. So we're going to be finding the inverse. So blank interchange the x values and y values of the relation. So that just means switch them. So inverse relations. Relation is just a set of ordered pairs. Interchange the x and y values. So when you have a set of ordered pairs, the inverse of that, you're just interchanging the x and y. So you're switching those x and y values. So a relation and its inverse relation reflect over the line y equals x, which we've already looked at. That is the linear parent function. It's a straight line that intersects at the origin. The process to find the inverse from a graph, a set of ordered pairs, a table, or mapping, you are switching your x and y values, and then you're just representing the new values in the desired format. Okay, so whatever format it was in at the beginning. So we're going to find the inverse of each relation. Okay, so this says, is the relation, which is your original, a function? So remember, we learned in the front, looking at your x values, notice these repeat here, so this would not be a function. Now we're going to use a table, and we're going to find the inverse of this up at the top. So remember, we just said to find the inverse, you're going to switch your x and y value points. So instead of this first, let me use a different color. Instead of this first point being 2, 3, we're going to switch it. It's going to be 3, 2. And switch the next one, 2, 0, 1, -1. 0, 0 actually stays the same. And then -1, 2. So all we're doing to find the inverse is switching your x and y values. So once we switch them, then it asks, is the inverse a function? So now we're looking at these x values, 3, 2, 1, 0, -1. Notice none of them repeat, so yes, this inverse would be a function. Okay, so let's go on to part B. This time we have mapping. So it says, is the relation, which is the original, a function? So notice there's only one line here, one line here, one line here, and one line here, which means all of those x's are different. So this would be a function. Now we want to change it. We want to change and find the inverse of this. So I'm going to go ahead and draw my little 2 circles here, or ovals here, and we're going. Okay, so then we're going to just look at these values and put them in the first one. And then I'm going to put those original x's over here. So now we have to look at each one. So notice the 2 is going to the 1. And then we have the 0 going to the -3. We have the 1 going to the -1. And we have the 3 going to the 3. So actually that one really didn't change. Okay, so now we're looking to see if the inverse, which is this one that we just drew, is a function. So notice all of them have only one line drawn from them, so which means it is a function. Okay, so now we're going to look at our part C. We're going to graph the inverse on the same grid. Okay, so what I would do is I would find some points that are on your graph here. So this is -2, 0. And then find your integer points. This is 2, 2. Okay, so it says, is the relation, which is the original, this is the relation, a function? So if we were to use the vertical line test, notice it would pass. It would only intersect at one place. Now we're going to have to graph the other one. So if I were to find the inverse of this, it would be 0, -2. So let's plot that. 0, -2 would be here. And then 2, 2. So that stays the same on this one. So there's my endpoint, and it's going to be curving up. So if we were to determine if the inverse is a function, notice that it would pass the vertical line test. So it would also be a function there. Okay, so this is going over functions and inverses. So if you have any questions, let me know.